Fun fact, in 2022, the United States used over 4.07 trillion kilowatt hours of electricity for industrial machinery, commercial equipment and lighting, and residential heating, cooling, and ventilation. Yet, 79% of that energy was generated from fossil fuels, fuels that contribute to over 30% of America's total greenhouse gas emissions, a number totaling 1,902 million metric tons of carbon dioxide equivalents. And as society gradually transitions to electric vehicles, heat pumps, and stoves, this already large electricity demand will only continue to grow. With the rapid rise in the Earth's average surface temperature, we must shift energy production from fossil fuels to more clean and renewable energy sources to minimize our ecological impact.
Investing in nuclear energy is crucial to meet global energy demand cleanly and reliably. While there is high political stigma around the safety of nuclear energy, modern advancements in fission and fusion technology have demonstrated the safety of nuclear technology. Studies over the last 6 decades have revealed the risk of accidents in nuclear power plants is low and declining, with more than 2,500 cask shipments of spent fuel being transported across the U.S. without any radiation leaks into the environment or cities. Plus, nuclear reactors provide energy at a maximum capacity of 92.5% throughout the year, providing a solid means of reliably meeting the demand of the power grid. Nuclear energy is also very sustainable as fuel that can be recycled into byproduct fuel that retains 90% of potential energy even after 5 years, and thorium is abundant in the Earth's soil. Recent developments in small modular reactors also make nuclear reactors scalable to small or bigger grids. The initial cost of building nuclear reactors may be a little high, the long-term usability of nuclear fuel will pay it off. However, building these types of reactors will take 2 to 10 years, and instead of waiting, we should also invest in other clean energy sources to power the grid, like wind, solar, hydro, and geothermal. The first of these three choices is not only efficient in ideal condition areas, like the American West and Sun Belt, but also provide a cheap way to generate electricity in more impoverished areas. Continents like Africa, where sunlight and rivers are abundant, could greatly benefit from solar technology and hydroelectric plants to create cheap energy and efficiently tackle the energy inequality in the area. Essentially, the best strategy to reduce carbon emissions from electrical production is to use clean energy sources like wind, solar, geothermal, and hydroelectric where they are most efficient and reliable, and invest in nuclear technology in an area where other sustainable technologies cannot reliably meet the grid demand.
Although switching to these cleaner energy sources will greatly reduce US carbon emissions, energy engineers must also consider that almost half of our emissions come from transportation and the residential commercial sectors. While the shift to electric vehicles and heat pumps will undoubtedly play a role in reducing this percentage, it fails to address the main root cause of these car-related emissions: America's lack of investment in public transportation. Currently, federal spending on public transit only accounts for 17% of total funds and is mostly not usable for day-to-day operations, where transit companies struggle the most. As a result, most transit operations don't extend to large residential areas and are usually limited to busy downtown areas. This makes it difficult for working civilians to rely on transit as a reliable means of transportation when stops are so far away from their homes, greatly contributing to the fact that about three-quarters of Americans drive alone and about 3% take public transit. As a result, improving these systems often takes little government priority. However, research shows that if we achieve more federal funding for public transit to improve daily operations and extend the range of local metro services, we can drastically increase the use of public transportation over personal vehicles. In fact, the Seattle public transit system accomplishes exactly this, and through their improvements to public transport, over 46% of civilians take public transit, almost 15 times the national average. This, combined with developing electrical buses and metros, will vastly decrease total transportation emissions.
As for housing, while investing in electrical heating pumps is a great way to optimize energy efficiency in homes, getting engineers to build homes with insulation and infrastructure in mind is more cost efficient and energy efficient. For example, if engineers place more focus on building homes with triple glazed windows, radiant barriers, reflective and foundational insulation, cellulose insulation, and insulation sheathing, the need for energy to heat and cool homes in the first place would be vastly reduced. Energy engineers must push for cleaner and more renewable energy sources, better public transportation, and better residential insulation to achieve a net zero emission world and curb the looming threat of global warming.